Right, so it's looking like your test will be on Friday, but I'll wait until tomorrow's or today's class to announce that. So I would imagine, so I'm making these videos the night before, obviously. So it looks like the test will be on Friday for my 5th years and my 6th years. So the test will be 4 questions, and it will be basically 4 triangles that I will pick from those questions 1 to 5, and that was done about yesterday. And you will have to answer the questions, quite straightforward. So I'm going to answer 4 questions in this video now, 2 on finding angles and 2 on finding sides. So let's make a start. This is going to be a very straightforward lesson. There's going to be very little teaching. You should all know this at this stage, but it's mainly just to kind of nail down a procedure that you can use. Okay, so we're going to write what we have. Sorry, first of all, it's find x. That's the question. Okay, so the question is find x, and we are going to use so trigonometry in this. So when our first trigonometry question, it's always a very good idea to write out. You wouldn't do this for every trigonometry question, but certainly at the start, when you come into a trigonometry question, you should really write out the silly old Harry business. So let's write that out, okay? So it's, can you see that? You can. So it's silly old Hitler couldn't advance his troops over Africa. And it's sine, cos, tan, and it's theta, theta, theta equals. So when we are answering our questions in trigonometry, we should have this thing visible to us at all times. So I'm going to try and park that somewhere on the question. Actually, will I try cut that out? Would that be a good thing to do? This is a lot easier when I was doing it virtually. So you guys will write this on a sheet of paper, and you can use that sheet of paper in all your questions. I can't do that because it won't fit on my screen. So my workspace is quite small since I'm using my iPad for this. Okay, so that's a terrible waste of paper, but anyway. Sorry, Mr. Rainforest. Okay, so I think you can see that. And this is our code kind of that we're going to be using. Right, so we're now in a trigonometry question. We have our silly old Hitler thing done. So it's now the correct thing to do would be to write out what we have and what we need. But in order to answer that, we must label up our triangle. So, well, let's start with the angle. We always call the angle theta. So this is the angle we're talking about down there. We call him theta. This x here, that's the opposite. And the 12 here, that's the hypotenuse. Sorry, because the right angle is there. Okay, so let's list what we have and what we need. We have theta, and we have the hypotenuse, and we need the opposite. So we now make a decision over here based on this information. So we have h, theta, and o. O, theta, but no h. In cosine, it's ah and theta. No good, we need oh and theta, so it must be sine. So in this question, we are going to use sine. So I then write out sine, and I put in theta. Sorry, I then start filling it in. So sine and theta for me is 37. So sine 37, sine theta. Then there's an equals. Then there's a line with an O, and in my case the O is x, and the h is 12. So I don't like doing trigonometry, so as soon as I can, I put sine 37 into my calculator. So I end up with 0.6018 equals x over 12. And now it's no longer a trigonometry question, it's a quite straightforward algebra question, so I can now cross multiply. So I have one fraction equaling one fraction because I introduced this 0.6018 all over 1 to make it into a fraction. So the answer is x, or 1x rather, is equal to 12 times 0.6018. So 1x must equal 7.2217, and we will call that x equals 7.22. So that's an example of a question that could come up on your test on Friday. Well, it looks like it's going to be Friday. It could be Wednesday, but when I'm recording this, but it's probably going to be Friday. Are we okay with that? All right, so this is the scrap of paper that you guys will have. So you've written that out in your test on extra paper or on the front cover or something. So you then come along and we'll park that to one side and we'll go on to question 2. So we still have access to our silly old Hitler. Now, brand new trigonometry question. Oh, we know what to do. Have, need. Let's label up our sides. That's the angle we're talking about this time is theta. So therefore this guy here is the opposite and this guy here is the adjacent. So what does that mean? That means that we have the adjacent and we have theta and we need the opposite. So we go over to our little code thing over here and we decide which one of these we're going to use. We're looking for something that has an A, an O and a theta in it. An A, a H and a theta, no good. An O, a H and a theta, no good. An A, an O and a theta, that must be it there. So we're going to use tan this time. So we set it up as normal. We write out tan and we start filling in the symbols. So it's tan theta, and theta for us is 56 degrees. Tan 56 equals some fraction, and on top of the fraction we have O, which is x, and we have 8 down there. So we can now put tan 56 into our calculators. Tan 56 equals 1.4825, equals x over 8. So therefore x by itself will equal 8 times 1.48256. So x equals 11.86. So the answer to that question is 11.86. Right. So that was question 2. Let's take a look at another question, question 3. Okay, so this question is slightly different because we have to find an angle. And the first angle we have to find is the angle y. So again, we write out what we have, what we need. And that means we need to label up our sides. So we always call the angle theta. Now, if the right angle is up here, well then this side down here, he must be the hypotenuse. And because this side here is touching the angle we're talking about, we call him the adjacent. So we have A and we have H and we need theta. That means we are going to be dealing with cosine. So I write out cosine or cos and I start filling in the blanks. So cos theta, well theta in our case is y, and that's equal to some fraction. And the fraction is adjacent, which is 5, over h, which is 14. So what does that mean now? That means that we have cosine of y is equal to 5 over 14, which is equal to 0.357148. So y by itself must equal to cos inverse. Okay, so we're going to write it out first of all, and then I'll show you on the calculator what to do. Cos inverse of 0.357148. Right, so hopefully you can all see that. What if I move it like that? Can everyone see that? Okay, is that straight? How about that? Now, it's quite handy to note here, guys, that this is in the calculator's mind or memory, okay? So now I want cos with this little -1 on it, cos inverse. So it is most certainly not that with a -1 or something silly like that, okay? There's a special symbol that we have to use, and that special symbol is up above the cosine button in yellow writing. So to access the yellow writing, we hit Shift. And we can now see that on my calculator we have cos inverse. And now I can put in the answer, which was 0.3571428. So that's going to equal 69.075. So y is equal to 69.075. You okay with that? Oh, and that should be in degrees. Now, if you have the old type of calculator, let's go through it with that. Okay. So, right. So we go Shift cos, so it's exactly the same, and it's 0.3571428, and that's equal to 69.075. So in the old calculator, it's the same process. It's Shift and then cosine here to get cos inverse. Now, some of you were saying that you weren't getting the same answers as I was getting because your calculator, and so I think your calculator might be measuring a unit other than degrees. So to do that, to change that back to degrees, probably the handiest thing to do is go Shift and then Setup. And see here the way it says DEG, RAD, and GRA. Right, so all three of those are different measurements of angles. And the one we always want to be in is the number 3. And to show that we are in degrees, we have a little d up here. If I was to go back in there and I was to turn it into radians, we now see that my little d has turned into an or. But I don't want it to be an or, I want it to be a degree. So if you lost the cover of your calculator in your bag, it might have turned on and changed the setup accidentally to radians. That might explain why your calculator was giving you the wrong answer. So just make sure it is set up correctly to measure degrees. Now I've never actually changed it on the new type of calculator, so I might just have a go at that now myself. So it's on Shift Setup, and we want to go angle unit probably. So we go 2, and we want degrees, which is 1. And do we have any indicator that we have? Oh, we have a little d there. So let's try that again, and then I go 2, and if I want to put it into gradients, which I think engineers use, I have a little g up here. So, but I don't want it in gradients, I want it in degrees, which is 1. And let's just try that. If I get sine 30, it should give me 0.5, which it does. Okay, so that was question 3. So let's take a look now at question 4. So where's my little piece of paper? Here it is. So that's the thing I'm going to use. Silly old Hitler couldn't advance his troops over Africa. And we're going to let's label up our stuff. X is what we're looking for this time. So we call that guy there theta. We call this guy here the adjacent, and we call this guy here the opposite. I'm trying to keep my video below 20 minutes. It's far too long as 20 minutes as it stands, but anyway, so have is opposite and adjacent, and we need the theta. So we go over here and we pick one of these that deals with O, A, and theta. O, A, and theta, and it's going to be tan. So I write out tan, and I start filling in the blanks. So tan theta, tan x is equal to some fraction, and it's O over A, so it's 7 over 2. So tan x equals, I don't need a calculator for that, 3.5. So x by itself must equal tan inverse of 3.5. So I can bring in my calculator for this, going retro. So shift tan, because I want tan inverse, and it's 3.5. And that gives me 74.05 x. Sorry, I'm left-handed, so I can't really leave the calculator. So x equals 74.05 degrees. So that was question 4. So hopefully you have some better idea now about what's going on for your test on Friday. Do not forget, guys, I just noticed myself doing one thing there because the questions I picked, very unfortunate. If you have cross multiplication happening, I don't know why that tick is there, that's weird. If you have cross multiplication happening, if you have, let's say, x over 7 is equal to 3 over 2. Okay, we have one fraction equaling one fraction. We're allowed to cross multiply, so we go that way. So I can say 2x equals 21. So x is equal to 21 over 2. X is equal to 10.5. Now, let's take a look at what happens if the x is on the bottom. The process stays exactly the same. Yeah. So we end up with 14 is equal to 3x. So that now means that x by itself is equal to 14 over 3. And that's 4.6. Recurring? Yeah. So x is equal to 4.6 recurring. So you need to be skilled at both ways, when the x is on the bottom and when the x is on the top. Or when the unknown rather is on the top and the bottom. So I'm going to leave the video there. Yeah, so have a look at this video and start studying for your test on Friday. We will have to move on to new stuff. I can't keep doing this until Thursday. But sorry, I don't know your test on Friday yet, but I would imagine your test will be on Friday. But I can't keep doing this until Friday. So yeah, we will be moving on to new stuff tomorrow, and you guys will have to keep studying this stuff until Friday. Okay guys, so keep studying that stuff and best of luck with it. I'll see you tomorrow.